Okay, thank you very much for that nice introduction. Again, my name is Atsuhiro Muto, but I go by Atsu. So thank you all for being here, and I would like to share my experience in Antarctica this past Antarctic summer, winter down here. So my presentation today is going to be sort of broken into three parts. First, I'll go through why we actually study Thwaites Glacier and Thwaites Ice Shelf. Then I'll tell you how we actually get to Thwaites Ice Shelf, which is where I was. And I'm going to share videos and photos that portray what it's actually like to live and work on Thwaites Ice Shelf. Now, so as a background, you might have been hearing a lot about Antarctica in general. And that's mainly because we are actually starting to lose a lot of ice from Antarctica pretty quickly. So this is just an example of an article that was in the Washington Post. It says that some of the new research is showing the researchers are showing that since the 1970s, we're losing a lot more ice than before. And there's one glacier in particular, surprise, surprise, it's Thwaites Glacier, which is actually losing a lot of the ice. Now, some popular media has picked it up and has called it the Doomsday Glacier, and that's not quite the word I would use as a scientist, but there is some truth to it. And that's because, again, the Antarctic ice sheet is losing ice, and in particular around the coast, but Thwaites Glacier is the one that's losing the most. So the figure I'm showing here is the latest research that just actually came out last week that used NASA's satellite laser instrument that can actually measure how much the surface of the ice sheet is changing over time. And what that showed for the past 16, 17 years is that around the coast, the surface of the Antarctic ice sheet and ice shelves are going down, meaning that we are losing a lot of ice. And in particular, what you're seeing in this figure on the right is basically where it's red is where we're losing ice. And this part that I've circled with green, which is the West Antarctic ice sheet, that's where you see a lot of red and near the coast. And there's been about 0.3 inches or 7.5 millimeters of global sea level rise coming from West Antarctica between 2003 and 2019. But if you actually just zoom onto Thwaites Glacier, which is, well, Thwaites is actually one of the biggest glaciers in Antarctica, but it's a comparatively small portion of the Antarctic ice sheet. But half of that, those 0.3 inches, or more than half those 0.3 inches coming from West Antarctica actually came from Thwaites Glacier. In fact, it was 0.15 inches. Okay. So we know that Thwaites Glacier is losing ice fast, and a lot of the ice is going into the ocean to raise the sea level. But we need to know how that's going to change in the future. So, and in order to do that, we need more data. So that's why I spent nearly 3 months studying, being on Thwaites Glacier and on its ice shelf to study it. And in fact, that was part of a big collaboration between the UK and the US. It's called the International Thwaites Glacier Collaboration. And it consists of 8 different projects. And this figure is just showing what kind of activities are going on for this ITGC effort. And what I've circled here are the project names or the acronyms for different projects. There are 8 different projects that has more than 100 scientists from the US and the UK. Now, my graduate students are actually part of the 2 projects. One is called Tarzan, the other one is called Ghost. And I'm mainly going to be talking about the Tarzan project, which is I was part of this past winter to go to Antarctica. Now, this is just a schematic figure of how the Antarctic ice sheet works. But what I'm going to be focusing on today is talking about this part, which is the where the ice sheet meets the coast, and it's called the ice shelf. And that's where the ice is flowing from the ground into the ocean, and it can actually interact with the ocean. And that's why we go there, and we're trying to figure out how this interaction between the ice sheet and ice shelf, the ocean, is going on. Now, we actually know that the ocean is getting warmer, and more warmer water is getting closer to the coast of the Antarctic ice sheet. But if you actually have something like this where there is warm water offshore, but if you have a ridge beneath the ice shelf, this warm water may not be able to get to the ice sheet. But if you don't have that kind of a ridge and pretty deep and flat ocean bottom, what this warmer water can do is get right to the below the ice shelf, and also go to what we call the grounding line, which is where the ice sheet starts to floating on the ocean, and melt the ice from beneath. And this is the main mode of the Antarctic ice sheet losing mass these days. Now, but we actually need to figure out what the ocean bottom looks like in order to see if this kind of interaction with the warm ocean and the ice sheet and ice shelves are going on to melt the ice. So what I do is use seismic surveys, which is setting off explosives and actually using hammers to create seismic waves to know the shape of the ocean bottom. Now, this is very similar to what the bats and the dolphins can do with the ultrasound. So what they do is they put out sound waves that we can't hear, but they can, to detect mainly for their food. Okay. And basically submarines do the same thing. And I use explosives and hammer instead of the ultrasound to measure the time for these seismic waves to travel to the bottom of the ocean and come back and convert that into the ocean bottom. So that is my main thing. That's what I was doing in Antarctica this past winter. And this is what it actually looks like to do a seismic survey using explosives. So there was a bit of a dynamite, basically a dynamite-like explosive that was below the surface. Let me go back. So one more time. Okay, this is using explosives. Okay. Then we can also use hammers. We just pound sledgehammer on the metal that is on the surface of the snow, and this is not as strong as the explosives, but we can still detect the seismic waves created by sledgehammers. Now, where all this all begins is actually back at Temple University. And this is a photo that was taken back in September where my graduate students, Louise Borthwick, Alex Wakaro, and Nolan Barrett are helping me test the equipment.
Okay, go ahead.
We send it down to Antarctica. So Nolan is swinging the sledgehammer, and we were making sure that all the equipment works before we send it all down to Antarctica. Then we packed it all into nice boxes, and we put it on the container truck of the UPS freight and sent it first to California. Then it gets onto a ship to go to New Zealand. Then it gets put on the plane. But this was all 2 months before I left for Antarctica. And my journey started in Philadelphia in early November. And this is basically the route that I took. So from Philly, I first flew to Houston. Then I crossed the Pacific Ocean to go to the Southern Hemisphere to Auckland, and I took another small flight to go to Christchurch in New Zealand, which is where the United States Antarctic Program has its facilities. Then from there on, we get on the US Air Force plane, and it takes about 5 hours to go to McMurdo Station, which is the big station in Antarctica. So this is a C-17 plane. This is in Christchurch in New Zealand. And this is what the inside of the plane looks like. We actually hitched a ride with a brand new front loader that was loaded onto the C-17. So it's a really huge cargo plane that can hold a lot of stuff. And there are about 100 people that were on this flight as well. And after about 5 hours, we land on ice. And this is what it looks like when we first get out of the plane. Then we spent about a month or so, a little less than a month, at McMurdo Station to collect all the boxes that were sent from Philadelphia, as well as spending time in training ourselves for working in the field. So these photos come from the crevasse rescue training. So first we do it indoors, then we take it outdoors. And we weren't very close to crevasses. We were, of course, trying to avoid them so that we don't fall in them, but we were just being trained just in case there was something unexpected in falling crevasses, we can rescue ourselves out of them. Then after about nearly a month, we depart onto Thwaites Ice Shelf. And first, we actually have to travel about 1,000 miles to this place called Waste Divide Camp on another US Air Force plane, which looks like this. So this is called LC-130, another cargo plane, but this time it has skis. So you can land almost anywhere where there is snow, unless there are many crevasses. Then from Waste Divide Camp, it's another 320 miles to finally get to Thwaites Ice Shelf. And to do that, we get on the smaller planes. One of the planes we took is this plane is actually old DC-3 plane that has the newer turboprop jet turboprop engines. And also we take what's called a Twin Otter, which is a much smaller plane, but very versatile. Again, and it takes about 10 flights with these two kinds of smaller planes to hold everything from all the way from McMurdo through this Waste Divide Camp and onto Thwaites Ice Shelf Camp, which from the air looks like this. We live on tents, and there are a lot of cargos that are lying on the surface. And we were just living, we were living with just 11 people in the field. So we all get one tent each to sleep in, but you can imagine that the communal space, such as this one, which is the kitchen tent, where we come to eat and cook and also have meetings, does get a little crowded.
Oh, so homey. Yeah.
So this is a scene of us talking after dinner, or maybe this is happy hour, because I see some boxed wines out there, but it does get a little tight, but it's still cozy. But if you want to move around, we all actually have to get up or put our legs up so that we can squeeze ourselves out of the tent. Okay. Now, so this video is showing me getting back to my tent one night. So where we started was actually a P flag. So that's where the boys go to the bathroom for number one. And I just fast forwarded the part where I was walking towards my tent. But we all got a tent each, this kind of tent. It's a Scott tent, which has this circular entrance and has a tie entrance so that you can cinch the door. But you have to squeeze yourself through. So whatever you're carrying, you throw inside the tent through this entrance to enter the tent. And we have very thick sleeping bags so that we don't freeze ourselves at night. But yes, we all go a tent each so that we don't have to be waking ourselves up with each other snoring. So once you get inside the tent, you cinch up the door again so that the snow doesn't blow inside. Now, almost every day, we get on snowmobiles and drive around with our stuff hauling on the back, get to different places so that we can actually go and do that, the seismic, kind of the seismic surveys that I was showing. So a part of the preparation station that I didn't tell you is that we all get training to drive these snowmobiles. And they're not that difficult to drive, but there are things that you can drive in terms of how fast you're allowed to go or not. But it's there to don't want to drive too fast, and also we learn basics of how to fix them in the field when we because we don't have mechanics with us. Then at each site, I used steam drills to make holes on the surface where I put down the explosives. So usually I put the explosives down close to the surface, or down to about 6 meters. So that we need to make the hole on the ice and put down the explosives. Okay. And this is the video of me putting together the explosives. And I actually have a blaster's license so that I'm allowed to handle these explosives. What these are, what this is these green things are the actual dynamite-like things, and the things that I'm just putting into this green tube it's a detonator that is connected to a small battery, and it puts electrical current through, and that there's a small amount of explosive in that detonator, which then ignites those green dynamite-looking things. So once the hole is drilled on the surface, I lower down these explosives, and I'm just tying off the wires to detonate them later. Then, again, this is the same video, but we detonate them on the surface, and we send down the seismic waves, which are then used to measure the ocean depth. Now, most of the time, the weather was fine, but there are times when we had some blizzard, and it never got really bad. This was the highest wind we had, but you can still see quite far. So we didn't actually experience any blizzards where you could see around you right out. We did not experience conditions, but when it's blowing as hard as this is probably about maybe 30, but it's just unpleasant. So in a wind like that, we don't work. And of course, it gets a little difficult to go to the bathroom. So this is a video of the bathroom tent that is being blown around in the blizzard, in the minor blizzard we had. But most of the time, the actual weather is pretty good, and sometimes we get out and enjoy ourselves. So this is actually one of the scientists, Ted Scambos, who was also my PhD advisor at the University of Colorado. So it was really good to catch up with him and work with him in the field. So just to wrap up, why do we study Thwaites Glacier and Thwaites Ice Shelf? And that is because they are losing ice fast, and we need more data to know exactly how much and how fast this will happen in the future. And how do we get to Thwaites Ice Shelf? We fly there. We fly all the way from Philadelphia to finally to Thwaites Ice Shelf, but it takes many, many days to get there. And what is it like to live and work in Thwaites Ice Shelf? Basically, it's fun. Now, there are some hardships because of the weather, or the work is hard, but it's mostly fun and I enjoy it. So just before I finish talking, I'd like to acknowledge the funding sources, which is National Science Foundation from the United States and the Natural Environmental Research Council in the United Kingdom. And there are many people who supported us in the field and off the field to make all this happen. So with that, I would like to wrap up and take questions. And I did notice that people had been asking me questions, but I had not been answering. So this is gonna be the moment where I do this. Okay, so I think the first question we had is, oh, it's just a comment. These are best slides. Thank you. How cold is it? Yes. Okay. So we go there in summer. It was summer in the southern hemisphere, so it didn't get that cold. Maybe the coldest it got was about -10, -15 degrees Celsius, which in Fahrenheit is, ooh, what is it? It's not colder, not that much colder than winter around here. How difficult to acclimate? I find it very easy to acclimate, so not difficult at all. Maybe when you first land in Antarctica, there's a tiny bit of a shock because, yeah, you're going from New Zealand, which is actually summer in New Zealand, so it's quite warm, and down to Antarctica, which is right around freezing. But again, it's not that cold, so it is not that difficult to acclimate. Is it true no virus in Antarctica? As far as the actual natural environment, I think that is true. But at the station, which is where we first land and spend some time, there are cold and flus that go around. And I know that there are no COVID-19 cases in Antarctica as of now, but people are being very careful and coming up with strategies to not to introduce it once the winter in Antarctica ends and people start going down again in September, October. Right, yeah, I had no gloves because it was actually not that cold. When the wind is high, so in that small blizzard we had, you have to wear gloves in that kind of condition. But most of the time, it was actually not that bad. So having your gloves off for several minutes is not a problem. Okay, so with the amount of ice melting, will it have an effect on salinity of the oceans? Yeah, that's a very good question, and yes, that is true. But that's actually one of the puzzles that hasn't been completely solved yet. So there are many scientists who are trying to answer that question more precisely. Right. So what happens is that if you melt the ice sheet ice or the ice shelves, that's fresh water. So you will actually decrease the salinity in the ocean. And how that changes the ocean circulation is actually, yes, it's being studied vigorously right now. Okay. Do the explosions have any negative impact on the glacier, or are they too small to have an impact? That's correct. These are very small, so it won't crack the ice. Are you not able to use other methods, sonar, to the ice due to the ice thickness? So basically, the actual fundamental physics of the sonar and the seismic techniques are the same. These are what we call the acoustic waves or sound waves. It's just different frequencies. But we actually would like to have submarines or the autonomous submarines that go under the ice shelves. But we are going to be doing that in the coming years. But that costs a lot of money and some time. So it's actually slightly easier, a little bit easier to just go on the ice shelf and do the seismic experiments. So what are we finding? We're still processing the data. So I only have preliminary findings, but there are deep cavities, so the deep ocean beneath the Thwaites Ice Shelf, so that there is more water going, more warmer water going to the Thwaites Ice Shelf and the Thwaites Glacier to melt from beneath. What was it like to not have regular sunrises and sunsets? Now, so I'm actually naturally not that sensitive to light when I'm sleeping, so I'm okay with it. But there are certainly people who are more sensitive to light, so that their sleep patterns get disrupted. But those people will wear eye masks and do their best to not to be affected by the sun. But a lot of times we work long hours, 10-hour, 12-hour days are pretty typical. So we're pretty tired by the time we get to bed so that we can get right to sleep. Did I get frostbite? no, because again, it was quite warm, and also we were being very careful. So even if it's warm, when there's a lot of wind, that's when you can get frostbitten. But we cover up ourselves pretty well when the wind is high. Okay. And what did we eat? So we actually had a lot of canned food and dried food that can just be boiled to become dinner. So a lot of rice, a lot of pasta, and canned meat. So we had some spam, then some dried fish, dried vegetables. So things that can be preserved for a long time. Do we have plans to enlighten the administration? Yeah, we do, but not me personally. It's going to be a collaborative effort because this is, so we went down as part of a big project called the International Thwaites Glacier Collaboration. So in a couple to a few years, I'm sure we're going to be coming up with a big report on what we find, which I don't know what, hopefully by that time the administration will have changed to someone who actually understands science more. That's being a little bit more political than maybe I should have been, but yeah, hopefully the our results will get used in better ways. What are my favorite or most vivid memories from this winter? So yeah, I always like the camaraderie that we build. So if we go to this slide here, or let's go back here. Yeah, so like I said, it was really good. It was really nice to be in the field with my former PhD advisor. And it's moments like this when we have a bit of downtime and the weather is perfect. So we just sit outside for 10, 15 minutes and just look around and appreciate what we have. And that's the kind of thing that keeps me going back to Antarctica. This was actually my 7th trip. Did you see any animals? Not on Thwaites Ice Shelf. Oh, actually, no, I correct that. We got visits from skua. So yes, I did prepare some slides. So these are skuas that come, and these 3 birds are actually picking on my seismic sensors. And they will come right up to you and they would like to steal any kind of food that you might have in hand. So you have to be careful. And at the station, we actually, at McMurdo Station, we see penguins and seals. So both of these photos actually come from this past trip. Okay, so, oh, I lost my chat window. Oh, there we go. Oh, thank you. Are there any more questions? So it is a little bit past 2 o'clock, but I can stick around for a little longer and answer more questions if you have any.
So it looks like that's the end of the questions, Atsu.
Okay.
Thank you so much for such a fascinating presentation. I hope everyone enjoyed it. And we want to thank everyone for joining us today. We hope to plan more Zoom activities in the future, and we certainly look forward to being able to host activities and events back on main campus. So please stay connected to the College of Science and Technology. Follow us on Twitter, Instagram, Facebook. We thank you again, and we hope you enjoy the rest of your day.